I'm a colleague of Tim Griffith's for a long time now, and I'm a neurologist interested in disorders of sensory processing, which includes migraine as will a sort of main clinical focus, and tinnitus, as we'll talk about here. And forgive the slightly oversimplistic or glib title here, but what I'm really wanting to talk about is just highlighting some issues about how tinnitus and key cognitive processes interrelate in various respects. I should hold my hands up and say I'm not an expert in cognition, although I have a certain amount of experience in general, and I would not consider myself an expert in tinnitus and cognition, but just somebody who, as many people, finds this interesting and would like to share some thoughts, ideas, and uncertainties. So a lot of the, to unpack some of these questions, a question that just comes up time and time again is, does tinnitus interfere with cognition? But on the flip side of that, I'd like to consider actually, do some of the mechanisms that related to causing tinnitus actually aid cognition, but if they've gone too far? And even, does tinnitus itself aid cognition? There's then this big question, is tinnitus caused in some part by failures of cognitive processes? On the flip side, actually, is it the result of overly eager or overly astute cognitive processes that lead to tinnitus? And there is substantial interest not only in hearing loss and dementia risk directly, but also tinnitus and dementia risk, including as a mediator of that. But also there's interest in the question of whether tinnitus itself can be a symptom, an early symptom of dementia, and also, is it protective on the flip side against dementia? So just considering, we start with tinnitus, and then we'll build up some kind of aspects of cognition and related factors around it. What do we mean by cognition? It means a lot of things, but here let's focus on attention, both sustained and selective attention, which relates very closely to working memory, auditory hippocampal interactions, which very much also well, as Tim has rightly said, may relate to working memory, but also longer term recall and recognition memory, and this very key question of auditory signal, including speech in noise detection, which is fundamental to perception and a lot of what the auditory system's trying to optimize. And then we're considering at either end, cochlear damage as a risk factor for tinnitus, and dementia and cognitive deficits, dementia at the other end. And then another issue that often comes up, tinnitus doesn't act in isolation, but if it causes a lot of unpleasant symptoms and reactions, how do those relate to these key processes? And then if we build in some of the mediators or processes by which some of these cognitive effects operate, from central gain and noise, inhibitory function, auditory predictions, and start to speculate as to some of the ways, this is probably not an exhaustive illustration of how these interact, you suddenly start to see actually this is not a straightforward or simple field, and exposing and getting at the heart of what the true key relationships are is quite difficult. So if we come on to mentions of studies not all reaching agreement with each other in their results, this may in part speak as to some of the reasons why. So just thinking about tinnitus alone, I think it's important in some ways to think that to some extent tinnitus is normal and needs to be explained as simply an excess to some degree of the result of normal processes, and that it's fundamentally just tied up with the ways in which the brain handles sensory signals per se. So a few key observations: that if you put people who have not previously reported tinnitus in a silent, soundproof room and get them to pay attention to what they can hear, more than half, or certainly around half, will hear a very faint noise matching the description of ordinary cases of tinnitus. Many of those, and then also the more than half of the remainder who don't, can temporarily elicit tinnitus with certain orofacial contractions. And then, even leaving aside those individuals, almost everybody experiences brief periods of tinnitus, often only lasting seconds in life, or longer after noise exposure. So tinnitus is the norm. There are also then illusions such as this Vickertone illusion, where you have a spectral gap in some ongoing noise, and when the noise stops, you get this sort of rebound effect of a tone coinciding with where the gap was. So tinnitus can be induced in anyone or is induced in almost everyone at some times. Moving on to some links with tinnitus and key cognitive processes, a huge amount of what we're calling cognition can be explained under attention, particularly sustained attention or selective attention, working memory, ability to maintain focus, reduce cognitive errors, etc. So anecdotally, people say they struggle to pay attention, struggle to keep things in mind and get distracted, and they make errors. I think obviously these are hard things to assess formally, because that's subjective, so one needs objective measures of cognitive performance. Tinnitus is almost always associated with underlying hearing loss, even with a normal audiogram, which is not so. A great deal of care needs to be taken to ensure we're not just focusing on the consequences of the hearing loss, not the tinnitus. And then there's the tinnitus related distress, sleep disturbance, affective reactions, and then any effects of diverted attention that are non-specific, that may result from tinnitus but aren't necessarily specific, such as how does pain affect cognition or other chronic symptoms. So some other things people might say that I thought are just noteworthy. I first noticed my tinnitus during a hearing test, and it's stayed ever since. I've had this one. I had certainly in myself and colleagues. I've started working on tinnitus, never having noticed it, and suddenly realized, oh, I have a bit of tinnitus. This phenomenon of causing it with jaw movements and then it becoming permanent. All of these suggesting that there's, this degree of plasticity or persistence of tinnitus once first noticed, even if the underlying hearing hasn't changed. And then slightly separately, this claim people often will say, I can't hear properly because the tinnitus is in the way, which I will return to in a later section. So just thinking about tinnitus and attention. So one way of getting at this is looking at vigilance tasks and response inhibition tasks, such as the Stroop test. And there have been a lot of studies, it's beyond the scope of this talk to summarize all of these, but some recent observations breaking it down into sort of presence or absence of tinnitus versus tinnitus distress suggest that it may be the distress caused by the tinnitus or the reaction to it that mediates the overall effect of tinnitus. There have been some reviews here, which concludes kind of a mixed set of findings, that actually it's hard to be certain about tinnitus interfering with attention, and that it's still not absolutely agreed upon that tinnitus does affect cognitive performance directly. Looking at the review on the right here from Tai and Hussain, considering both speech and noise performance and these selective attention and inhibition and other features of cognitive control, firstly noted that these haven't tended to be measured in the same studies, but again have shown that there's actually a number of slightly indirect factors such as tinnitus severity, hearing and age that may mediate effects of tinnitus on cognitive control rather than these necessarily indicating direct relationships. Another potential link with tinnitus and attention is not simply does it interfere, but can attention actually contribute to the generation of tinnitus? And there was a prominent review on this by Larry Roberts, suggesting that actually attention may be grabbed towards discrepancies between predicted signals in the brain and what input is there. And that's been one of the things, one of the numerous inspirations behind the model that myself and colleagues put forward a few years ago, showing how a number of factors may combine to essentially affect this property called precision, which applies to all predictions in the brain and all other representations like incoming sensory inputs. And that if too much precision is applied to spontaneous activity in the auditory pathway, it overrides predictions of silence. And I'll talk about the sort of resetting of predictions a bit later on, but that reinforcement through attention once noticed might be a very rapid positive feedback loop. Here, that once it's noticed, it's inherently attention grabbing, attention further increases the gain or precision, and you've got a self-perpetuating cycle. Looking now at sort of handling of signals and compensating for cochlear damage, which is the main risk factor, through central gain and central noise, and how this, and also considering direct or indirect effects on signal and noise detection. It's just worth noting that in terms of complaints of reduced hearing, people often say I struggle to hear because of the tinnitus. The frequency of tinnitus, as we probably all know, coincides with the region of hearing loss. So it's very difficult to know if the tinnitus is really causing this problem, or the tinnitus is getting blamed because it's the thing that's there in the same frequency region. It might be possible to actually examine this, although I don't think anyone's done it, looking at hearing thresholds and how they change when you transiently inhibit tinnitus with residual inhibition, which shouldn't affect the underlying hearing thresholds themselves. But that's just an aside here. So again, I think there are some inconsistent results, but some recent evidence is suggesting that, you know, once age, hearing, and other factors are accounted for, there isn't necessarily a direct interference with a variety of auditory, perceptual, and discrimination tasks. So in terms of you know, how tinnitus might relate to beneficial processes in cognition, sort of optimizing the processing and handling of sensory signals, there's a couple of arguments that are often put forward, which is tinnitus or hyperacusis or both the result to some extent of central gain, trying to make up some of the lost or degraded input signal. And this is a popular model here. This is from some years ago now, from Roland Shatter and the colleagues, just showing that if you have hidden hearing loss as evidenced by reduced wave 1 in your ABR, if you turn up the gain in appropriate compensation to restore sort of normal higher levels of processing, that in the process this might amplify spontaneous activity and cause tinnitus. And then there's another slightly more nuanced view that draws a distinction between central noise, which is multiplicative, so the sort of slope of your input-output function, and central noise, where there's an additive effect, for instance, in panel B, and these might sort of differentiate into causes of tinnitus and hyperacusis separately. And another very specific take on central noise is this stochastic resonance view that actually it draws on a wider principle that's got some quite good supportive evidence that a certain amount of noise in an information or signal detection system is actually advantageous. So looking at the circle here, you have a pure sine wave signal with no noise. It might just struggle, if it's very faint, to get over the threshold for perception as indicated by the lines, but you add a bit of noise and that just helps it over the limit at random or stochastic time points. And on the right here, showing that actually gives you a much stronger or a much more meaningful response than with no noise. But then you add too much noise and everything is persistently activated. And so there's a sweet spot in the middle. And that somehow, so the thought is there that actually tinnitus could relate to the intentional and adapting adding of noise to sensory signals as a way of optimizing auditory cognition in terms of signal detection. I think there's a really interesting kind of tinnitus plus syndrome that probably should get a bit more attention, something called visual snow syndrome. And tinnitus is a feature in the majority of cases, but not all. And what it's named after is this visual snowstorm effect, where there's a lot of visual noise, like a badly tuned analog TV. It's shown in panel B here. But there's a number of other features, including very prominent after images, as in C. And in D, this what they call the blue field entoptic phenomenon, where you get little tiny streaking white dots that move chaotically across your vision. And to some extent, these are normal phenomena, but are very prominent and impossible to ignore in visual snow syndrome. But sort of just thinking about some of the questions in tinnitus as to whether tinnitus itself is an intrinsic signal that we might call it that's subject to too much amplification or is inappropriately perceived, or whether it's an actual a separately added source of noise like in stochastic resonance, which is then inadvertently perceived, whereas it should have only been used as an aid to processing of true signals coming from the outside. And it's hard to know from tinnitus alone, although I'd refer back to visual snow syndrome to get clues that might help us, at least in some cases, in that although there's some doubt as to the origin of the visual snow itself and the tinnitus, some of the features that are there, we actually do know the physical origin of these. So those streaking white dots are white blood cells moving through retinal capillaries when red ones were expected, and that is seen as a white dot. So we know that this is coming from the periphery, but the defect is that awareness of it is not being filtered out. Those small fluctuations are receiving too much gain or priority or retention at higher perceptual levels. So moving on now to consider inhibitory function. So the ability to tune down or suppress or ignore signals that are there but are not behaviorally relevant or advantageous at the current time. You'll probably all have heard of the frontostriatal gating models of tinnitus, which are in parallel applied to chronic pain as well. So here this is just showing a summary of studies showing grey matter loss in these two chronic symptom conditions, which tend to coincide most around midline prefrontal cortex regions, particularly these subcallosal and orbitofrontal regions, which have roles in inhibition. And then giving rise to quite a nuanced model, although the bit I want to highlight here is that there's a negative feedback loop from these prefrontal regions via the thalamic reticular nucleus, which has an inhibitory role on ascending sensory information through the thalamus that then feeds up to cortex. And that if there's insufficient inhibition, it releases these ascending sensory inputs. So in a sense, this is a gain or amplification model, but affording quite nuanced cognitive control to what is and isn't inhibited. There's some very recent work that I think it's hard to draw a lot of conclusions, but I thought the approach was interesting, looking at stimulus and response inhibition in tinnitus. And this is combining two approaches, one of which is TDCS, direct current stimulation to the dorsolateral prefrontal cortex, which has been done before, and there is some evidence suggesting some at least temporary suppression of tinnitus to some degree. But then they've followed on with auditory Stroop task training, where you have to switch what modality you're responding to and suppress what would be perhaps automatic responses. So this is the stimulation they've done. So in a visual Stroop task, you might switch between having to say the word that is represented and the color it's in, and they had an auditory equivalent of this. And forgive me, sorry, I've forgotten to label the colors, but the blue group received the active stimulation. The Stroop training was valid in both. The orange group had the sham stimulation, and there wasn't statistically significant difference between the two approaches, but there's just this hint that that after the TDCS there was some reduction which we know about, but then both groups seems to be a little bit of reduction of tinnitus loudness following the Stroop training, which was significant. There just wasn't a placebo group. So I think this notion of inhibitory control training is interesting and warrants further study. Looking now, referring to what Tim was saying about auditory hippocampal interactions, which may be so crucial for links between hearing loss and dementia. There's been models put forward of tinnitus as a pervasive auditory memory trace, initially from Dirk de Ridder, who'd proposed that in more severe cases of hearing loss, it's like an auditory amputation, and that the signal actually the missing signal needs to be drawn from parahippocampal memory to maintain this sort of homeostasis, or to maintain some activity of the deafferented cortex. So that's very much a sort of top-down origin of the tinnitus percept. And then we've proposed an alternative account where actually the origin is still a bottom-up spontaneous signal, but that there's a key top-down component, which is if this is recognized, which is part of memory, as a true auditory object, that gets remembered, and you can't sort of forget the recognition of that signal, and that's why tinnitus becomes chronic. And this is an example that I often use. If any of you have seen this before, you'll probably instantly recognize what this is a picture of, and otherwise it'll take a variable amount of time to realize that this is a dog with its back to us, hind legs here, sniffing around, its head is there, front leg here. Once you've seen that Dalmatian dog, you can't unsee it. If we go back and you've seen it, you'll see this straight away. And we think of sort of recognition of that pattern or meaning within what's otherwise noise may be key to tinnitus. And that may come through auditory hippocampal interactions as one potential source. Running a bit more with the idea of prediction formation. So there's very strong evidence now that cognition in general and wider brain function relates to balancing of sensory inputs and signals with prior predictions and models of the world, and optimizing the balance and priority between these. And just to give a little bit of an overview, if we think of precision as this weighing up between your priors or your existing predictions and your sensory input, or which sometimes termed the likelihood, and striking an optimal balance gives you the best, most consistent, most accurate perception. But if you get it too far in one direction, there can be problems. So too much precision applied to sensory inputs, if that occurs in a region of hearing loss, can lead to spontaneous activity in that region being perceived. And then if too much sensory precision is afforded in a generalized fashion, you end up with things like the visual snow syndrome, where sources of noise and irrelevant variance and variability still get perceived at a higher level because they influence perception. Conversely, if you have too much precision on your predictions themselves, you can end up with hallucinations, sort of fundamentally top-down generated complex percepts. And we've previously put forward a model of this based on people with musical hallucinations in moderate to severe acquired deafness, and here the thought is that that leads to a very high level of spontaneous auditory activity just from all the gain changes we've talked about, but that it's very low precision, and that what happens is that activity, it's there, and it's very strong, but it's shaped by very higher predictive mechanisms in areas responsible for representation of melodies. And because you don't have a precise sensory signal to set it straight, those predictions are just allowed to kind of run away with themselves. Looking into evidence of whether there are abnormalities of auditory predictions in tinnitus, motivated by the model I've talked to you about, we'd tried to see whether we can use brain EEG responses, mismatch negativity, to actually find evidence of altered predictions. So the idea is that if you have a series of tones that vary, for instance, in their intensity here, between R, which is a reference, or R-6, a slightly quieter number of decibels, and you have these deviants where your intensity changes unexpectedly upwards or downwards, that a sort of neutral observer with no tinnitus, they just predict that the next stimulus will basically be like the current one. So the stimuli are the black bars and the predictions are the colored lines, and they should have roughly equal sized responses to unexpectedly louder and unexpectedly quieter stimuli. But in tinnitus, if your predictions are skewed by this very low level, quiet, ongoing learned sound, you might get larger surprise or deviant responses when your stimuli become less like that, and smaller ones when they become more like that. And so these are the sorts of kind of time domain signals we're looking at, and you've got this negative mismatch negativity response when there's an unexpected change. And we've found some evidence suggesting that this pattern of results as expected is seen with these much larger negative responses when you move away from the tinnitus than towards it. But this is an area of ongoing interest. There are other explanations that need searching for, but it's an ongoing line of inquiry. And then interestingly, there's been a very different take on auditory predictions as a predisposing factor to tinnitus. looking at sound sequences represented by colored dots here, with differing degrees of predictability from fully random. These are tables of transition probabilities on the left, so it's just equally likely it goes from any tone to highly predictable on the right here, and seeing whether you can decode from MEG brain activity the upcoming stimulus. And this red patch is just the degree to which people's brain is representing the stimulus that's about to occur at the point of this line, and showing that this is actually more strongly correctly represented in people with tinnitus than controls. And these are stimuli well below the tinnitus range. So the idea that people may in part get tinnitus because they're better at picking up subtle regularities in auditory sequences, I think warrants further study. And then finally, I realize I'm running over a little bit, links between tinnitus and dementia. There is some evidence showing that in a retrospective case control way, prior tinnitus or having received a diagnosis seems to raise your odds ratio to about 1.6, which is quite striking, even after apparently accounting for a number of comorbidities, including, importantly, hearing loss. Tinnitus can also be a symptom of dementia. It's certainly overrepresented in semantic dementia. And this is just showing areas of excessive atrophy linked to tinnitus in people with semantic dementia with and without tinnitus. And most of these are in these inferior prefrontal regions related to inhibitory control that we've talked about previously. And then there's an interesting line of research coming out more recently. Again, this is epidemiological, so it doesn't prove causation, but this was seen in non-Hispanic, but not in Hispanic populations from equivalent databases, just showing that hearing loss without tinnitus, this red colored block, was associated with decreased cognitive performance, but hearing loss with tinnitus was associated with normalization of that, leading to this interesting notion of actually other processes of tinnitus somehow maintaining cognitive mechanisms or protecting from cognitive decline. And just moving back to what Tim's talked about as potential links, you wonder is tinnitus somehow making up for impoverished input, or indeed addressing these structure function interactions that might help ameliorate the deposition of pathological proteins. But this is, as you can see, a controversial area, and we're not even sure if there's an association or which direction it runs in, but hopefully time will tell with the right sorts of studies. So in summary, I think there's more questions, possibilities, and theories than answers at present, but I'm hopefully convinced you that tinnitus is deeply tied up as part and parcel of the various cognitive processes related to auditory perception, with likely causal influences in both directions in a number of respects that need careful disentangling through future studies. So thank you.